Tonight, imagine walking through a forest 50,000 years ago. You hear footsteps behind you. You turn around. The face staring back looks almost human, but not quite. It smiles. It carries a stone spear. It speaks a language you cannot understand. And it belongs to another kind of human. For most of history, we believed we were always alone. One species. One story. One destiny. That idea was wrong. Not long ago, Earth was home to several different human species. They walked the same valleys. They hunted the same animals. They watched the same sunsets. Sometimes they fought. Sometimes they traded. Sometimes they even had children together. The human family tree was never a single straight line. It looked more like a tangled forest. Our own species, Homo sapiens, appeared in Africa roughly 300,000 years ago. The oldest widely accepted fossils come from Jebel Irhoud in Morocco. They push the origin of our species back by nearly 100,000 years. But Homo sapiens were not the first humans.
Some scientists once believed intelligence belonged only to us. The evidence no longer agrees. In 1856, workers cutting limestone in Germany's Neander Valley uncovered strange bones inside a cave. At first, nobody knew what they had found. Some thought the skeleton belonged to a diseased modern human. Others imagined a lost soldier. Years later, scientists realized the bones belonged to an entirely different human species, the Neanderthals. For decades, they were portrayed as primitive. Popular books drew them as bent over. They were shown as slow, violent, barely capable of thought. Most of those images were wrong. The first Neanderthal skeleton had severe arthritis. Its posture reflected illness, not the entire species. That single mistake shaped public opinion for generations. Modern archaeology paints a very different picture. Neanderthals built sophisticated stone tools. They controlled fire. They made clothing from animal hide.
Imagine if every ancient human had survived. Modern cities might look completely different. Different species could work together, learn together, argue together, perhaps even govern together. Instead, one by one, every branch disappeared. By around 40,000 years ago, Neanderthals were gone. The Denisovans vanished soon after. The tiny people of Flores disappeared. One by one, the human family tree lost its branches. Why? Scientists still debate the answer. Climate changed rapidly. Ice sheets expanded and retreated. Habitat shifted. Food became unpredictable. Small populations became isolated. Disease may have spread between groups. Competition for resources intensified. And then, there was us. Homo sapiens spread across continents with remarkable speed. We built larger social networks. We exchanged ideas over vast distances. We developed increasingly complex tools. Some researchers believe those advantages slowly take the balance. What would happen if Neanderthals had never disappeared? Imagine boarding a train beside someone who belonged to another human species. Imagine classrooms teaching the history of 4 or 5 living human species instead of one. Imagine governments writing laws for minds that evolved differently. It sounds impossible. Yet for most of human history, it was reality. Around 60,000 to 70,000 years ago, small groups of Homo sapiens began leaving Africa in larger numbers. They were not entering an empty world. Europe already belonged to the Neanderthals. Across parts of Asia lived the mysterious Denisovans. On isolated islands, other human relatives had carved out lives of their own. This was not the arrival of humanity. It was the meaning of humanity. For thousands of years, these groups shared the same landscapes. They followed the same rivers. They tracked the same hordes. They searched for
The oldest stories are rarely written in books. They are written in bones. Every fossil pulled from the earth is a message from someone who can no longer speak. Most of those messages arrive incomplete. A single tooth, half of a jaw, a fragment of a skull buried beneath thousands of years of sediment. For generations, scientists had to reconstruct entire lives from only a handful of clues. Then, ancient DNA changed everything. Instead of studying only bones, researchers could study the instructions that once built those bones. It was like finding the blueprint instead of the broken building. The field transformed almost overnight. In 2022, Svante Pääbo received the Nobel Prize in Physiology or Medicine for his pioneering work on ancient genomes. His research helped reveal relationships between modern humans, Neanderthals, and Denisovans that had remained hidden for tens of thousands of years.